As
Yeah, we can see your screen and the
yeah,
audible. Thank you.
yeah, you can see the slides are good. Well, this is Anime4You, intelligent analytical framework for anime recommendations and personalization using AI and big data analysis. My name is Kaiho Chang. I am from Sentinel Secondary. And people who helped me on this particular paper is Ishmael Rico from University of California, Tal Lee from Purdue University, and Yusun from California State Polytechnic University. So Japanese anime cartoon, well, more commonly referred as anime, has gained a massive popularity over the past few years, especially in North America. We are starting to see subscription-based streaming services pop up, such as Crunchyroll, Netflix, and even Amazon now offers some sort of like anime options. For reference, the anime industry is currently estimated to be at $20 billion, and it is still growing. On a personal level, I own like a few hundred dollars worth of anime merchandise too. And however, the main problem that this paper aims to solve is the problem that plagues all mediums of entertainment, is of what to watch next. And there are solutions out there currently, however, they're not ideal. The main solution out there right now is just using the internet to find what to watch next. Challenges with that is you're searching on the internet where there's so many different ways to look, right? If you can see on the screen right now, right, Google is obviously the main one, right? Quora is another popular option for looking for, like, asking questions, right? Even within Reddit alone, we have like r/anime and r/anime suggest, and there's like other countless subreddits out there that I have not mentioned. This is just like the challenge with looking at the internet is just there's too much information and too many factors at play for people to sort out what recommendation is good for them, and it makes it impossible for them to decide. Within like online communities, there's also another big problem where different users post different recommendations and often argue that their case is better. Like a lot of these posts are very long and consist of many back and forths requiring a lot of sorting through and prior knowledge. And sometimes people speak highly of an anime because the anime is infinitely bad, like Boku no Pico, right? People say it's good for fun, but as the outsider, you wouldn't know. Searching online can give you a general sense, but it takes time and previous experience. You look at the little like web of like maps. That's just like a interactive map on GitHub that shows like all the different recommendations linking to each other, and you would see how a user can navigate. The next big challenge on the current recommendation systems out there is content cap. Like when it comes to what to watch, premium like streaming services such as Crunchyroll and Funimation and Netflix in general have really good like industry level recommendation algorithms, or just they have professional staff and people writing recommendations. However, anime licensing is incredibly expensive and can cost millions of dollars. For example, if you look at the bottom of the screen, Neon Genesis Evangelion would be a good example where you can Crunchyroll, the streaming service, would not be able to recommend you that anime because they don't have the license for it, right? And if you look at the top right, the bottom right, Netflix wouldn't be able to recommend you Fate Stay Night because they don't have the license for it. I mean, there is the alternative to go on My Animelist, which is the biggest like anime Wikipedia, I would say, but then that runs into the aforementioned problems about too much information. Here is the overall process of the paper. We got our data from My Animelist, as I mentioned, the biggest like source of anime. We found a data set on Kaiho, which is a free and open like data set website where we can download data. And then from there, we got our CSV files. We had to do some data manipulation to that CSV files, and we fed it through pandas, which is a Python-based data sorting algorithm, to create the data frame, which is going to be fed into ScikitLearn, which then is used for the SVM model. And then once we have the trained algorithm, we use user inputs to output a prediction. In terms of data manipulation, what we had to do was essentially, if you look at the top right here, like we take this anime, for example, Kimi-no-wa, for example, the data came with the ID, the name, the genre. However, the genre was in such that it's separated by commas and was not, you can't really feed this through pandas because pandas don't take string, like a string input, basically. So what we had to do was, you see on the bottom, we separated all the genres out, and if the original data contained the tag for it, right, it will be a 1, and then everything else will be a 0. So you can see on below. Okay, so the methodology that we're using to build this machine, the machine learning algorithm is Python. Okay. To do this, we're using a nonlinear support vector machine, which classifies as data points, or in this case, vectors, in this case, data points, using linear regression. This method allows us to have multiple variables of consideration, which makes the prediction more accurate. SVMs, short for support vector machines, are also very easy to build and come with built-in optimization. And it's designed to work with unstructured data, and it scales well linearly, with high dimensional data, which is the case here. As I mentioned, we use ScikitLearn for the machine learning algorithm itself, and pandas for data sorting. Beyond that, we also conduct experiments are performed to calculate and compare accuracy for determining the most appropriate machine learning model through the implementation of, like we did implement through experiments, and then we did a few experiments on, some variables that can impact accuracy. Experiment 1, as you can see here, this is the code for experiment 1. Obviously, if we look at it, the X variable contains all the genres, such as action, adventure, cars, etc. And PD read panda it basically is the row of data it's taking. right? And this experiment is to determine whether which role we select for training affects accuracy. And so for the first data point we had, we're using row 0 to 100. For the second one, we're doing 100 to 200, and for the third one, we're doing 200 to 300. And here is the data in graphs. If you look at the data here, 0 to 100 has a 48% accuracy, 100 to 200 has 57, and so does 200 to 300. I mean, one significant issue to note is that although we were using the same data set for training and validation, which as you can see leads to high accuracy because the machine's literally being tested on what it was taught. However, that shouldn't be an issue because our data is 11,000 rows long. So realistically, it isn't going to have a significant impact on, yeah. Some confounding variables would be ranking. Row 0 to 100 from the original data is the highest ranking anime, and that could lead a lot of problems because if you think of it as convenience sampling, there might be clusters such as people generally tend to like action anime more, and therefore the top 100 is more like action based than the rest of the population. Yeah. Here is experiment two code. Ignore the slide. In this case, we tested the effects on genres and accuracy. So for the first one, you see we only selected action, drama, comedy, horror, and then we did the test. And then for the other one, we had dementia, demons, drama, itchy, fantasy, and game. And for the third one, we just have different genres. Here is the data. So the way we conducted the experiment is that the first one is all the what I consider common genres within anime. The second one is a mix of both common and uncommon tags. Like dementia is uncommon, but fantasy is very much common. And then the third one is just every single uncommon one. This test is mainly for us to see if we can reduce the number of tags without and increase efficiency without impacting accuracy too much. For the purpose of this test, we're using row 0 to 100 for the training data. The common one actually scored pretty low at 11% accuracy. The mix of both scored even lower at 7. And what's surprising is that the uncommon tag scored a really high score of 18%. I think some like explanation on whether why this occurred is because using uncommon tags for data points for the SVM actually like like shape the linear regression better, because there's so many anime out there with the same tag action that would make the SVM's linear regression not as accurate. Some related works that are covered in the paper include Mangaki, which is a similar recommendation system, but it features like buttons such as like, dislike, and neutral, and it works with other forms of mediums, as you can tell by the screenshot there. This was basically, yeah. Analytical is another one we study where it uses this one is very similar to ours. However, it includes other factors that we didn't have in our data set, and Sasha, we didn't really think it had a necessary impact on enjoyment in anime, such as voice actors and directors. However, they did use a different model. They did use a vector space model instead of a SVM model, and it also requires the user to train the machine before using it, unlike ours where it's trained based on all the available anime. Recognise is the last one we looked at. Recognise works with other mediums such as light novels. Basically, how this works is you put in 5 anime, and you have watched and you liked, and it creates this user profile. And this profile is put through a hybrid filter from a database and gives a user 5 recommended animes. Like Magaki, the user has to have watched the previous shows or else it just gives out 5 of the most popular animes. And however, it's really good. However, the main downside is it's only applicable on a large scale, such as websites or streaming services. For future works with this paper is malintegration. Because our data was a year old, it might be not accurate. And with malintegration, we can also have user feedback, because Mal is a rating community. Mal allows us users to rate animes. From there, we can, if we have more time, we can integrate Mal into our system so that when you rate, it builds a profile. So the more you watch, the more accurate the recommender is. We should have better training data instead of having training data together with our testing data, validation set. We should have separate data. The main limitation of the paper, this analysis is severely impacted by my lack of understanding what I'm doing, and further analysis is beyond the scope of this paper. Thank you.